In this video, we discuss solving systems, and we are going to be solving by graphing. First, we need a definition. A system of equations is two or more equations considered together. The solution of a system of linear equations is the ordered pair that solves all of the equations in the systems. So to solve an equation means when you plug the numbers in, everything works out and it's true. So take a look at the system I've given. It is customary to use that brace, that large brace on the left-hand side, and then to put all the equations in the system next to the brace. Now what we're looking for is an ordered pair that works in both equations. For example, if x is 4, 4 minus 1 is 3. But if I plug 4 in for x in the first equation, do I get 3 there as well? And the answer is no, I do not. So 4, 3 is not the solution. So we're going to learn in this video how to find that actual solution by graphing. There are 3 methods that we're going to learn in this course for solving systems. As I mentioned, the first one is graphing. We're going to learn that in this video. Then we'll do another video on substitution and a third video on elimination using a matrix. Here are 3 systems which have already been graphed. The solution of a system is the ordered pair that works in all the equations. Well, what that means is that it's a point of intersection. So the solution for this first graph is the point 1, -3. In the second system, the solution is the point 4, 2. And in the third system, the solution is the point, I'm going to assume -1, 3. They didn't give me any numbers on my axes, so I'm going to assume they counted by ones, and it's -1, 3. So you can see that once you've got the graph, the solution is super easy to pick out. So let's do an example from scratch. Now notice both of these equations that I've given you are in y = mx plus b form. Y is isolated, so the number on the end is the y-intercept. So I'm going to plot a point at 4, let me use a darker green, and then I'm going to count a slope of -2/3. That means I go down 2 over 3. So starting at the green dot, I go down 2 over 1, 2, 3, and that's a slope of -2/3. I'm going to do that again to help me draw my line. Down 2 over 3, and now I'm going to attempt to connect those dots with a straight line. That wasn't too bad. All right, my second equation has a y-intercept of -1. So I'm going to put a dot at -1, and now I'm going to use the slope, which is +1, and I'm going to rise 1, run 1. From the orange dot, I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then I connect those dots with a straight line, and the point of intersection here is 3, 2. So that's the solution of the system, 3, 2. Now we're going to watch a video where we solve a system on the TI-84. Before we begin, please notice that in both of these equations, y is isolated. So we're going to press y equals. Now I've already typed in x plus 5, and I've already typed in the negative 1/4 x. So both equations need to be in there. Notice that the equal signs should be highlighted with little black rectangle. Now I'm going to hit zoom 6. That gives us the standard viewing rectangle. It's usually a good place to start. Now notice the red and blue graphs have a point of intersection, and it appears to be at -4, 1. So let's find out for sure. We're going to hit second and then the trace button. Look at choice number 5, intersect. That's what we're looking for. So we're going to choose 5. Then the calculator is asking us to verify the first curve as y1. To do that, we hit enter. Now we need to verify the second curve as y2. Hit enter. Then we need to make a guess. So this is where you move the cursor close to the point of intersection and hit enter. And we were correct. The point of intersection is -4, 1. So let's write that down. -4, 1, and that is called the solution of the system. Now let's solve this system by hand. Notice these equations are not in slope-intercept form. Rather, they're in standard form. So when equations are in standard form, it's sometimes easiest to use the intercept method, which I call cover-up. This is where you alternately plug in 0 for x and y. When you plug in 0 for x in the first equation, the x goes away and you have y = 4. When you plug in 0 for y in the first equation, the y goes away and you have x = 4. 0, 4 is 0 up 1, 2, 3, 4 on the y-axis, and 4, 0 is over 4 on the x-axis. And so I'm going to draw a blue line through those 2 points. All right, that's not too bad. Now, the second equation is also in standard form, but I'm actually going to isolate y in that equation because when I look ahead, I can see that I'm going to have fractions. So I'm going to isolate y. So 4x minus y equals 6. I'm going to subtract 4x from both sides of the equation. I get -y equals -4x plus 6. And then I divide by -1 to get positive y. And -4x becomes positive 4x, and plus 6 becomes -6. So I'm going to use green. I have a y-intercept of -6. 1, 2, 3, 4, 5, 6. And I have a slope of +4. So I go up 4 and I go over 1 from the green dot. 1, 2, 3, 4 over 1. I'm going to do it again. 1, 2, 3, 4 over 1. And I can see that my point of intersection is right there. And that happens to be the point, looks like 2, 2. Now notice something. Because I'm human, my graph is not perfect. So my point of intersection, sometimes isn't perfectly clear. Now we're going to do this same problem using the calculator. Now before you begin, you have to isolate y in both equations. So I'm going to subtract x from both sides of the first equation to get y = -x plus 4. And I isolated y on the last slide, and I remember that I got 4x minus 6. So let's graph these now on the calculator. So we're going to press y equals. Now I've already typed them in, -x plus 4 and 4x minus 6. Now we're going to graph by hitting zoom 6. We have 2 lines with a point of intersection. Now we're going to hit second trace. Second trace. We're going to choose number 5, intersect. First curve, Y1, enter. Second curve, Y2, enter. Make a guess, hit enter, and we can see that the point of intersection is 2, 2. 2, 2, and that's called the solution of that system. In summary, the solution of a system of equations is the point or points of intersection of its graphs. You can graph the equations using the intercept method, slope-intercept form, or on the TI-84. Thank you for watching.